The following 5 projects are oscillator circuits, and they use the transformer which generates an AC voltage. When I turn on the slide switch, you'll hear a fairly high-pitched but quiet sound. I am now going to place the whistle chip over the C1 capacitor, and with the added capacitance, the sound is lower in pitch. Next, I am going to place the whistle chip on the left side of the transformer, and the pitch is higher now. When I place the C3 capacitor directly above the R5 resistor, there is a much lower sound, and actually it's just a clicking noise. The red LED flashes. Finally, I am going to replace the R5 resistor altogether with the photoresistor. And then when I wave my hand over the sensor, the sound will change, as does the oscillator frequency. And you can make some neat sound effects. This is the transistor tester. This circuit allows you to determine whether or not a transistor is good. In this case, we're going to be using the NPN transistor, and the voltage meter is set to the low setting. The slide switch is already on, and when I push the press switch, if the transistor is good, the meter will deflect all the way to the right. If the transistor is bad, the voltage meter will deflect very little, if at all. So this is a great way to determine whether or not you have good or bad transistors. This is an adjustable voltage divider. I have the voltage meter set on the low setting, and when I turn on the slide switch, because the lever on the adjustable resistor is all the way to the right, the meter will also deflect all the way in that direction. Right now, the voltage over the R4 and RV resistors is equal. But as I move the lever on the adjustable resistor toward the left, the voltage decreases until it's finally at 0 when the RV lever is all the way on the left. As I move the lever back toward the right, the voltage increases. The next 8 projects are flashing capital letters. First will be the letter C. I'm going to turn on the slide switch, and the letter C flashes on the 7-segment display. It is controlled by the alarm integrated circuit, and like in previous projects with the 7-segment display, different connections using 2 snap wires create the different letters and numbers. I am now going to do the letter E, and for that I will connect the G point. Now you have a flashing capital E. For the letter F, I'm going to remove this connection. For an H, I am going to make more adjustments. For the letter P, I am going to move 1 double snap wire. I'm going to make some more connections to make the letter S, which can also be the number 5. the letter U, and finally the letter L. The following 6 projects feature whistle chip sounds. When I turn on the slide switch, you'll hear a very faint sound coming from the whistle chip, which is right here. Now for the first variant, I am going to move the whistle chip to these 2 points, and now the sound is louder. For a faster sound, I am going to place the whistle chip between these 2 points here over the C1 capacitor. And now the sound is temporal. It's not continuous. Now I'm going to place the whistle chip back where it was for the first of these projects, and then replace the C4 capacitor with the C3 one. Do you hear any difference in sound? Now I am going to replace the capacitor with the C5 one. Notice any difference in the sound now? Finally, I am going to reinsert the C4 capacitor and then place the whistle chip so that it is between points B and C. Lastly, I'm going to connect it between points C and D. And now you hear a very rapid clicking sound. This project is called LED Music. When I push the press switch, the red and green LEDs light up. The song that the UC module is playing is actually controlling the LEDs, and they will stay on until the song is finished playing. Unfortunately, there's no speaker for you to actually hear the music, and it shouldn't be too much longer until the LEDs turn off. And then you can push the press switch again for the next song. And the songs have different lengths, so the LEDs will stay on for different periods of time depending on the song that is playing. I'm not going to do all of them, but I just wanted to tell you how the circuit works. For the first variant of LED Music, I replaced the press switch with the photoresistor. Now when I shine light over it and wave my fingers between the light and the photoresistor, the LEDs will come on. And then I can also use the photoresistor to turn them off. Or I could just wait until the song is finished playing and they'll go off on their own. But I'm going to turn them off again. Now, light is controlling whether or not the circuit is on or not. For the second variant, I actually placed the PNP transistor, and I will control the circuit by touching these 2 contacts with my fingers. I can wait for the song to finish playing for the LEDs to turn off, or I could touch the contacts again and the LEDs will turn off immediately. You may need to wet your fingers a little bit for better conductivity. This is an alarm recorder. When I turn on the slide switch, you'll hear a beeping sound. And then after you hear the second beeping sound, turn off the slide switch and push the press switch. You'll hear the recording of an alarm. And then one of the 3 pre-recorded songs will immediately follow. And there you have it. Push the press switch to stop the alarm or music. I removed the 2-snap wire from the top left corner of the circuit, and I'm going to turn on the slide switch. Oops. And now the alarm sound should be different. More like a police car siren. Followed by a song. I moved the 2-snap wire all the way to the right side of the alarm integrated circuit. And then when I turn on the slide switch, it's not very loud, but it's supposed to be a machine gun sound. I'll try one more time. Yeah, it's not very good, but you have the idea of what the sound is supposed to be. And it's the same principle as the previous 2 projects.